Hi guys, welcome to this video. So today we will solve one more LeetCode question, which is question number 153. So whatever question we are going to solve today and in the upcoming videos will be of same type, that will be based on binary search, and we will solve all our questions on login time. Okay, these are some of the questions which are mostly asked in the coding interview rounds. So this comes under medium. So let's understand the question. So it is saying find the minimum in the rotated sorted array. So from the statement we come to know that our array will be rotated and it will be sorted. Let's understand how. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, so this is our example, this is our original array, and this is the array which is rotated 4 times. So how it becomes like this? So if you see over here, notice that rotating an array, so this is the original array, after one time rotation, so our last element comes to forward. So similarly, after 4 times, if you push forward, so 7 will become here, 6 will come after it, then 5, and then 4. So after 4 times, this becomes like this. Hope you understand this question. So it is saying given the sorted array nums of unique elements, return the minimum element in this array. So we need to give the minimum element in the array. Yes, this question can be solved very easily with the O of n, but here the algorithm says like we need to solve it by log of n. So when the algorithm is asking for log of n, so binary search is usually a great choice because it divides your array into half every time. So it gives you log n complexity. So let's understand this example. Given array 3 4 5 1 2, so this means it is been rotated 3 times. Okay, if you push this array 3 times, 5 will come forward, then 4, and then 3. So 3 4 5 is at one place and 1 2 at one place. Okay, now the output is 1 since the minimum in this is 1. Okay, similarly 4 5 6 7, so array has been rotated 4 times, and this is the rest of the array. So what is the minimum of this is 0. Okay, similarly this has been rotated 4 times and there were 4 elements, so it becomes the same, and the minimum is 11. Okay, let's understand the constraint. So the constraint is n is equal to the length, and our n will not be more than 5000, and the array values will not be more than minus 5002 plus 5000. So considering this, we no need to take care of like if our integer value is will be like very large or something, so we don't need to take care of all those things. Okay, all integers of nums are unique. Okay, so we no need to bother about whether we'll get some duplicate elements or not. So nums is sorted and rotated between n and times. So this is one of the crucial things which they have given. Okay, so let's understand this question, how we can solve it. Like we said, we can use the binary search for this. Okay, so we need to think of some way how to tweak the binary search so that we can use this for our advantage. So if you see over here, so this is our element 3 4 5 1 2, right? 3 4 5 1 2. So our minimum value is 1. So if you see this array, what it is saying to you, so the number is in increasing order, as we know. So if you see, this is our increasing order, and again this is our increasing order, right? So there are two increasing way. So our array will be always in the increasing form, so whether it is interrupted in between or not. Okay, so our minimum will always be at such position that your right side value is also greater and your left side value is also greater. So suppose this is my left and this is my right. Okay, so in the binary search we take out the mid, right? So let's take out our mid for this. So it is 0 plus 4, so our mid will become 2. So this is my mid. So let's compare with our right side. So if you see, my mid is greater than my right. Okay, so my mid is greater than my right, so whatever, so our middle portion will be somewhere here. Okay, so my mid is greater than my right. Okay, so whatever, since we need to find a minimum element, so we are sure that it will not be here. Okay, since it's mid, since it's always increasing order, both the things are always increasing order, but it's mid only, it's greater than my right side. Okay, so there is no chance that my minimum value will be in this side. Okay, since it is very increasing order, and it is also increasing, but it is somewhat lesser, that's why its mid is greater than the right side. Right, since my right is smaller than my mid, so the chances is my minimum value lies over this side of our array. Now if we come over here, what if our mid is smaller? So if our mid is smaller than my right, so in this case what happens, my smaller value will come under the left side. So what we will do, we will shift the left and right. So in this case, if my mid is greater, so I'll shift my left over here. Okay, so now my resultant array will only have 1 and 2. Okay, similarly, if my right is smaller, then what we will do, we will move our right this side. Okay, so that we can search over here. So at last, so whatever will be the value left, that will be our resultant array. Okay, let's write the algorithm. Maybe this question will be more clear when you write the code. Okay, if you see over here, I'll write the code. So let's take my left, I'll just write L. Left is 0, my right is nums dot length minus 1. Okay, so I have initialized my left and right. Now I'll have a while loop. So this is like a normal binary search algorithm. Okay, if it will run till my left is smaller than my right. We will write our mid, so it will be left plus right divided by 2. Okay, now we'll check, like I said, if my mid is smaller than my right. Okay, since my right side is greater, okay, so but I have to shift towards the left. Since my right is already greater and I have to find the minimum value, so I have to shift towards the left. So in this case, how we will shift the left? So I'll just assign my right to mid. Okay, else my mid is greater, right? If my mid is greater, then I have to shift towards the right. So how we can shift towards the right? We need to shift towards the so how can we shift towards the right side? So I have to push my left towards the right, so it will be mid plus 1. Okay, after this, whatever will be in our left, that will be our result. Okay, let's run this example. So it got accepted, and let's submit it. So it got submitted. Okay, so hope you understood this question. It is one of the important interview question. Let me know if you have any questions further. Thank you.